PPT completely. I just took out the things what is needed, and it will be helpful, to put it sequentially and also, to talk about that. So, but it is overally, it is, it has included all the things. But if anything is left, we can go through ma'am's PPT later. Okay. Okay, so the first thing is what is Markov assumption? For example, let's say you have a set of words, okay, let's say, or you have set of events, let's say T1, T2, up to Tn. So from the probability, like how do we do? So we basically say, okay, probability of first event, then multiplied with probability of second event given. One second, let me just make it. Huh. So probability of first event multiplied with probability of second event given first. Then again multiplication probability of third event given second and first. Like that it will go. And then at the end again it will be multiplication of last event given all the previous events. Okay. So what here we are basically saying is, one second, I just want to change my pointer. Yes. So this is what we already know from probability, but what Markov is saying, or this Markov assumption, is that the current state or the current event is dependent on just its previous. Okay. So for example, if I say just its previous, then it would be first order Markov rule. But in that case, what will happen? This probability of first event, or we can say the initial probability of occurring that first event, then probability of second event given the first, probability of third event given the second. Here, if you see, we are excluding T1. We are only taking just the previous one. So like that, it is probability of last event given probability of just its previous one. Okay, so that is what Markov assumption is. It says like the current state is just dependent on couple of previous state, and based on that it would be defined like whether it is first order Markov rule or second order Markov rule. So if you see, it is just like also our bigram probability, right? Like we say, okay, the second word is dependent on first, third word is dependent on second, like that. And if I need to take second order Markov rule, let's say in the exam or wherever it is saying, so it means T3 would be dependent on T2 and T1, because we need to take two previous states. So like that, probability of Tn will be dependent on n minus 1 state and n minus 2 state. Okay, so this is what Markov assumption or Markov rule you can say. Okay, so taking that formula in mind, so there is a question like so I have a training data where it says on what day what is the weather, like for example today is cold, tomorrow is hot, or day after tomorrow is warm. So like that, let's say for 10 days data we have. So from that, we are interested to know like when this sequence occurred. That means for 4 consecutive days, warm day, like the warm. So if we go ahead and see this rule, what we are saying the first probability, like the initial state probability, then probability of second state given first, probability of third given second, like that. So here, if I see, I am interested in, let's say, for warm, I am saying it's 3. So and let's say hot is 1, cold is 2, and warm is 3. I have just labeled it. Okay. So in that case, how I will present? Okay, I want to know what is the state sequence of 3, 3, 3, 3. And this pi is nothing but what is your initial vector here, like what is the probability that your first day, let's say we have 10 days, right? So the first day, what is the probability of being hot? So they have given, okay, it's zero point 0.5, and for cold it is zero point 0.3, and for warm it is zero point 0.2. This is our initial probability. And if I need to find out what is the probability of all three, all these like sequence, warm, 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 so what it should be? It should be probability of first day warm, right, which is nothing but zero point 0.2, that is given here. If in case it is not given here, like the initial probability, and they have given a data set, from that you need to find out, okay, for 10 days, or like basically you take the count of warm days, and then you divide it by total number of days. Okay, here if you see, so like out of 10 days, they are saying 5 days it is hot, 3 days it is cold, and 2 days it is warm. Okay, that's how the initial probability gets calculated if it is not given already. So the first is we need to calculate what is the probability of first day being warm. So since it is already given for warm, it is zero point 0.2. So I'm taking zero point 0.2. Then multiplied with the second day is a warm day, given the first day is warm day. And that you can get it from this state transition picture. So what it says, like for example, if I take hot day, so zero point 0.5 is the probability that like after one hot day, there will be another hot day. I mean, next day will be hot. Similarly, first day, if it is cold, then there is also zero point 0.5 probability that the next day will be cold. So that's why it is a recursive probability kind of thing. If you see the, it is initiated from cold, again it is ended on cold. So like this for hot and warm. And if I want to know, okay, what is the probability that one day is hot and the next day is cold? They are saying it is, if you see the arrow mark, it is going from hot to cold, and it says zero point 0.2. And the similar fashion, like if you want to know, like, okay, what is the probability of first day is cold or any day is cold and the next day would be hot, it will be zero point 0.2. So like that, as per the arrow direction, you need to consider, okay, from hot to warm, since it is that arrow is towards warm, so that means your next day will be warm and the previous day is hot. That's how you have to understand this probability. I mean, as per this state picture given here. So we got, okay, zero point 0.2 is our initial probability of getting the first warm day. So for getting the second warm day, the probability would be, okay, second day is warm given the first day is warm, right? So for that, if you see warm to warm, like first day is warm, second day will be also warm, so it will be zero point 0.6, right? So that's how we can write zero point 0.6 in place of A33. And again, the same thing, same probability will come here. So like that, so we will get here zero point 0.2 into 0.6 to the power 3. Okay, so that's how this kind of Markov chain or Markov rule we can apply, and we can calculate the probability of a sequence. Okay, so what is pause tagging? So in pause tagging, see, if I say it here, here what we are seeing, whatever we are observing, like for example, hot, cold, warm, and we are also getting the output also in the like in a sequence which is hot, cold, warm. Okay, so it is very straightforward thing. But whenever we are coming to pause tagging, we are going to get two things which I will discuss it later. But let's understand what is pause tagging. So pause tagging means a sentence is given. Okay, before that you will have a training data set where they will have this kind of sentence, like some sentence will be the input, and they will mark, okay, for example, the is a determiner, Late is a noun, paint is a noun, is verb, unsafe is an adjective. Like that, they will have already labeled the data. So by taking that labeled data into consideration, we need to find out if someone is saying, okay, I have this sentence, you just do the pause tagging. So based on our initial training data set, I need to find out what should be the appropriate tag for the or late, paint, is, and unsafe. Okay, that is what we are interested. We are interested, like, okay, if someone is giving us a sentence and we have already a training data set, and based on that training data set, I will find out, okay, each word, what is also known as lexicon, is like each lexicon represents what kind of tag, and why it is useful. So basically, if you see, we in our pre-processing of any text data, we do stemming or lemmatization. Stemming is nothing but, for example, friendly is a word, and we do it as part of pre-processing because it will also help us creating embedding, then you create model using that embedding, etc. So if you see what is stemming, for example, if I have a word like friendly, and in stemming, what we do basically, we just stem it, like at the end we just remove ly and it will be friend. Whereas lemmatization, like if it is friendly, it will be also friend, but for example, yes, for example, let's say friendlier. So in stemming, it might just remove er, it will say friendly after doing stemming, but whereas in lemmatization it will give you the root word, which is friend. Okay, so but again, it depends on what kind of data set you have and what is your domain, what problem statement you are handling. So based on that, you choose, okay, whether you will go for stemming or lemmatization. And while you do that, if you don't know, okay, if something is a verb or something is a noun, so if you know that, it will help us to do all this stemming or lemmatization, because I can put stemming or lemmatization, let's say, on the friendly is, I think it's no, sorry, what is it? It's adjective, right? But I can't put the same rule on a noun, correct? So for that, you need to know, okay, what is the right pause tagging for a particular word. And then coming to parsing, so parsing is actually something which will be covered, I think, fifth topic onwards. So you will come to know that we will need pause tag to build a tree, basically to parse a complete sentence, and you need to build a tree so that you can get different kind of verb phrase, noun phrase, all these things. And then the third one is named entity recognition and information extraction. So if you know about this entity recognition, for example, I'll say Sachin is playing cricket. So there it will identify Sachin is a person's name and cricket is a what is game. So those kind of things, for if I need to find out, I have to also know, okay, whether it is a person, I mean, whether it is a noun, whether it is a proper noun or it's a verb. So those kind of things, also pause tagging is helpful. Then machine translation. So in case of machine translation, if I say, okay, Sanjukta is studying, and if I don't know that Sanjukta is a person name, and I want to translate it to, let's say, in other language, French or something. So what will happen? Like your model will try to translate Sanjukta also, but since it is a proper noun, so or a person's name, so you shouldn't do the translation, right? And the last one is selecting word of specific parts of speech in pre-processing the document. So again, it is somehow similar kind of thing. Okay, then open and closed classes. So what here they are saying, closed class means For example, the preposition, auxiliary, pronoun. So these are all, very restricted numbers are present for these kind of things. Whereas for verb, noun, adjective, so new things are coming up, whether it is in English or any language, because of the impact from other language, or the change in the people's mindset, etc. For example, has or coolness, or hot. The meaning of hot can also change the context. So there are new words which are getting introduced for all these kind of things. So that's why it is open class. I mean, you can't say, okay, there are this much amount of words or nouns present in English. Maybe after 10 years, you can see there are much more words are getting introduced. But whereas in closed class, I mean, till now, whatever we are seeing, there are like fixed set of things. Okay, so as I told you, right, we will have a training data set, and by using that training data set, we need to predict, okay, what should be the post tag. So there are different type of data sets available. One of them is pen tag set. It is like it has been developed by Pennsylvania University. So where they basically, for example, this the where DT means it is determiner. Similarly, for JJ represents to maybe adjective. But whereas if you see some other data set, they might say something else. Like in case of JJ, they can say ADJ, adjective. So it can vary depending on the data set you are using, or even if you can also create your own data set. You will say, okay, I will use AD instead of ADJ. Okay, so there is no hard and first rule that you should use this, but for conventional purpose, people always use this kind of notation. Okay, so hidden markup rule. It is okay. So before I go through all these things, whatever written here, so let me tell you, hidden markup model. It is actually based on base rule. So and it is one kind of generative model. So if you remember in our machine learning class, uh, we will have one posterior probability which is equal to multiplication of prior and then the likelihood, right? So what we say there, like, okay, probability of a class, do I have that now? Okay, so probability of a class given a data set is equal to probability of class multiplied with probability of data set given a class. So if you see, since we are talking about a probability distribution, if I want to generate the data, I can also do. How will I do? Because I can take that probability of data given a class towards, I mean, in the left, and in the right hand side, I can take probability of class given the data. So in that way, we can generate the data. So that's why it is known as generative model. Basically, wherever we use this Bayesian rule, all these are generative model, whereas the other things like your logistic regression or any other ML model where we don't consider these probabilistic things. So these are all a deterministic model where basically we need to find out a decision boundary to divide the class. But in case of generative model, we can also generate the data because we are dealing with probabilistic things. Okay, so while we do this pause tagging, what we are interested in, suppose I have, let's say, T1 is, suppose I have this W1, W2, W3, W4. These are my words in a sentence. And uh, so these things, these W1, W2, W3, W4, these things, we can observe it, right? But whereas the tag T1, T2, T3, T4, these are all hidden state, because if you write a sentence or if someone is saying a sentence, what you can observe the word. That tag is something underlying things that is present. So you can say that is hidden state. So, for example, in this case, let's say I have assigned one tag T1 to the word W1, similarly T2 to W2, T3 to T3 to W3, T4 to W4. So, what they say is like when you are going from T1 to T2, so the probability of T2 given T1 is known as transition probability. Okay, if you see probability of Ti given its previous tag, current tag is Ti, previous tag is Ti minus 1. So if I am interested to know what is the probability of T2 given T1, then I am going to find the transition probability. I mean, this is the word they use basically in post tagging, but this is the thing which we have already seen. I think everybody knows this. And then the initial probability is like, okay, what is the probability that the T1 tag will occur first? I mean, it would be my tag corresponding to the first word of my sentence. That is known as your initial probability. And what is the emission probability? Emission probability means it is basically the probability of a word given its corresponding tag, that is known as emission probability. So again, this emission probability and transition probability are specific to post tagging. It might vary. People sometimes say observation probability or something like that in actual HMM. So that will be covered in the next lecture, basically, like ma'am has covered. But however, from post tagging point of view, you need to remember three things. One is the initial probability, that the probability of the first tag, then the transition probability, like the probability of going from one state to others, the nearest state, and the emission probability is the probability of the word given its tag. These are the things we are going to basically consider while we do post tagging. Okay, so if you see, like at the starting, I told what is Markov rule, and again we also heard here. I think somewhere I told hidden Markov model or hidden Markov rule. You can say. So what is the difference here? So the difference is in our Markov rule. If you remember that that warm day example, so we didn't have any hidden state concept, right? We have only output. Like for example, okay, today is warm. What will be tomorrow's day status? Like whether it is warm, cold, etc. But whereas in hidden Markov rule, you are going to deal with two things. One is output, and another one is hidden state. And in terms of post tagging, where HMM is also used, actually there are lots of application of HMM, but in post tagging, it is one of them. So in post tagging, the output is the words, and the hidden states are the post tags. Out, you can say output, or you can say what we can see, basically uh, the observation probability, right? So that will deal observation, because we can see the words, we can't see the post tags. So that's why the hidden states are post tags and the output is word. And then again, HMM is an extension of Markov chain. Okay, so if you see the base rule, right? We already know, right? For example, probability of let's say x and y is equal to probability of y given x. So it's basically the you can take, this is your posterior probability and this is your likelihood, and this one is your prior probability. And then the denominator thing, if you remember in our statistics class, we used to ignore it, because for example, if I sorry, so for example, if I have to find out, let's say I have a sentence, for example, a smart dog, right? So someone says, okay, can you tell me whether a smart dog will be DTJJNN or DTNNNN? So in that case, if I have to find the probability and I need to do the comparison, this this total probability will be same for all the things, right? So that's why what they do, they completely ignore this denominator. So it's similar to what we have used for that Bayes classification, right? We just ignore this and we say okay, the posterior probability is equal to the likelihood into prior. The same thing we are using it here. And argmax we need to take whenever we have two things to compare. Like if someone is saying like as I told, like I have an example, a smart dog. So are you going to tag this a smart dog as dtjjnn or dtdtdt? So in that case I need to find the probability and compare wherever it is maximum. I have to take that thing. So that's why this argmax things comes into picture. Okay, so these are like the same thing. We have just added this argmax. Okay, so now uh, as part of post tagging, we are interested to know what is the probability of, for this one, let's say. So as part of post tagging, we are interested to know what is the probability of this tag sequence dtjjnn, where dt is determiner, then jj is adjective, nn is noun. So what is the probability of tag sequence this, given we have a sentence, a smart dog? It can be a sentence or it can be a part of a sentence. Okay, so if this is the case, how we should proceed? Okay, so the same thing, I mean, it is like, technical word, it is written here. So I'm interested to know what is the probability of tag given word. Okay, and here you need to also keep it in mind, this tag is not just a plain one tag, it's a sequence of tags. And similarly, this word is also a sequence of words. So basically, we are interested to find what is the probability of one tag sequence which is composed of multiple tags, given I have a word sequence which consists of multiple words. So here we are dealing with two sequences, and we are trying to find out the probability of tag given W. So in that case, how will we do? We can write it as like probability of T1. I think normal probability how we do, like the first one, then probability of T2 given T1. So like that. Because if you remember from our markup, first order markup rule, we have ignored the rest of the previous states. We are only saying the second state is dependent on the first, the third state is dependent on second. So that's how we will calculate this transition probability. As I told, transition probability means the probability of going from one tag to the other. And since we are dealing with a sequence of tag which consists of T1, T2, T3, like that up to Tn, so I can expand it in this way, okay, using the first order markup rule. And if it is specifically written, no, you need to use second order, third order, according to that your probability will change. Okay, so that is the first thing. And then the second thing is what we are, if you see here, we got pt, probability of tag sequence, which is nothing but probability of first tag into probability of second tag given first, probability of third tag given second, like that. What about this one? It is saying probability of word sequence given tag sequence. So here also what we are saying, see, in our normal sentence, a tag, or sorry, a word, for example, smart. This smart is only dependent on its corresponding tag, right? Like if I need to say, okay, smart. So we all know, let's say there is no ambiguity on the smart. Smart is only can be adjective, or dog can only be, let's say, noun. So since there is no ambiguity, so in that case, this smart is only dependent on its tag, which is adjective. Similarly, dog is only dependent on noun. and is only dependent on this dd. I don't know, maybe it's determiner. Okay, so that's why if I want to find out what is the probability of smart given all these tag sequence, I don't care what the sequence says. I am only interested for this smart position. Let's say it is second position. What is its corresponding tag? Its corresponding tag is JJ. So I am only building a relationship between JJ and smart. I am not interested in other tags. So that is why this probability of word sequence given tag sequence is represented in this way. Probability of first word given the given its tag multiplied with probability of second word given its tag, like that. Okay, I hope this thing is clear, because this is what we, I mean, will help us to finding the post tagging. Okay, so if I
Sorry, one question here.
yes.
So, the second part you explained, like probability of word one given the tag of the corresponding word. Okay.
Hmm.
So, what is like on the first part, probability of T1, then P2?
This
Uh,
one, this one.
this one is like sequence of word. The word sequence is
No, no, this is sequence of tags.
tag sequence.
Hmm.
Uh, uh, they are checking probability of second tag given the probability of T1, like that they are checking in the first part, and then they are checking the word sequencing given the tag sequence.
Right.
Okay, cool. Thank you.
Okay, so if I take this example, let's say I have a part of the sentence, a smart dog. Okay, or maybe I can say it is just a sentence, complete sentence. Okay, so if I am interested to find out what is the probability that, actually it is written it as a joint probability, but for easier understanding, you can think it as probability of this tag sequence DDJJNN given a sentence a smart dog. Okay, so if you remember in this way, it would be, you can easily remember. So probability of the tag, because in our post tagging we are interested to find out the probability of tag given a sentence. We are always given a sentence, like in exam or anywhere, someone will give us a sentence and say, okay, you find its tag, right? So that means we can, what we can say, find the probability of tag sequence given a word sequence or a sentence. So if we apply the same rule, what we are saying here, so probability of, so let's set this, I mean, first let's take this one. So we are interested for probability of tag sequence, PT, which is probability of DD given start, because here we are assuming, okay, this is start of a sentence. So probability of DD given start multiplied with probability of JJ, which is the second tag given the first tag, multiplied with probability of third tag given the second tag. Okay, this is what we got as probability of tag. Then multiplied with probability of word given tag. And here again, word is a sequence, T is also, tag is also a sequence. And how we will deal with, we will say the probability of word, any word, is basically dependent on its own tag. I am not interested for other words tag. So that's why we can write it in this way. So we'll say probability of a given DD, which is nothing but the determiner, multiplied with probability of smart given JJ, probability of dog given NN. So that's how we will basically multiply all these things and we will get the probability of DDJJNN given a sentence. I think this is what written here. Okay. So as we saw, we are dealing with two kind of probability. The first one is state transition probability, where we are transitioning from one state to other state. State means the hidden state. And what is the hidden state here? In post tagging, the hidden state is the tag. So So that's why it is written as probability of current tag given the previous tag. And how will you find it? Because they will provide you a data set, right? And from that, what you are supposed to do, you need to find the count of previous word and current word, like where they are occurring together, how many times they are occurring together, divided by the previous word. It is something like the bigram probability. And again, if it is already told you need to use second order Markov rule or maybe trigram, then you need to change here as per your trigram things. But mostly they are giving this. I mean, they don't say. I haven't seen any second order things. And then coming to the observation or emission probability, so it is nothing but like observation, what you can observe. You can observe the word. So that means you need to find out probability of word given the tag. And how will you find that? You need to again see wherever this tag and its corresponding word, how many counts are there divided by that particular tag count. That's how you are going to calculate the probability of like for P of Wi given Ti or P of Ti given Ti minus 1. Okay, so here there is an example. So we are basically interested to find out, okay, what is the probability of, if you see they have already, uh, labeled it, that like that is a determiner, then flight is a noun, like that they have already did the labeling. And we are like something is asked, okay, you need to find the uh, pause tagging for a particular sentence, and how will you find it? They have given an example, like let's say probability of noun given the determiner is equal to wherever these two are coming, like see the sequence here is matter. While you are counting, you should always see like first is determiner, second is NN. Okay, so in that way you need to count everywhere, like maybe starting from this topic, if not even this topic, the whole NLP topics, the sequence matters. You shouldn't alter this. You have to see, okay, the like first DT then NN. So in that way you need to find the count, then divided by the DT count. And in the data set, I mean, after counting, they found, okay, this value is this much and the denominator is this much. That's how they find this probability. Okay, in the same way, so suppose I'm interested to give in a data set, I'm interested to find, okay, what is the probability of is given it is a verb. So what I will do, like I will see wherever verb is coming first and then is there. So I will take that count divided by the probability of the verb. And as per the data set given, these are the values, and which is divided and we got the value. Okay. So there is this example, like secretariat is expected to race tomorrow. We have a sentence like this. So what they are saying, one second. Yes. So we have a given sentence, this one, secretariat is expected to race tomorrow. And what they are saying, okay, if you see, this is an ambiguous statement because this race can be a noun, it can be a verb. Whereas all these things are, there is no, for this particular lexicon, there is no ambiguity. Secretariat, we know it is noun, is verb, expected is a verb, to is a determiner. And in some of, I don't exactly remember, in one of the data set, I think maybe that is that Pennsylvania University data set or something, where instead of DT, determiner, they say the tag of to as this capital TO. This is nothing but determiner, but in their data set, they are using it like this. Okay, so if you see, all the words are like quite straightforward. Everybody knows what is its tag, but for race there is ambiguity because we don't know whether this race is a noun or a verb. Okay, so and one point I would like to stress here, whether a word will be tagged to a word, noun, or any of the tag always depends on your data set you have. For example, if I my data set what I am using, I will use where let's say 90% of the time race is noun. So in that case, if you are taking if you are trying to find out the pause tagging for this sentence, then definitely whatever probability you find after the calculation etc, you will see okay your race will be also noun because it is dependent on your data set. Okay, so like wherever the ambiguity things will come, it will be always data set dependent. Okay, so since there is a ambiguity like whether this race will be noun or verb, we want to see okay what should be the right tag for the whole sequence. And as we already know, like okay for these words there is no problem, but this is the word where everything dependent on this, right? To find the complete sequence, I need to also know what is the tag for this race. So how we should proceed? So the first thing is like as we saw earlier, right? The probability of tag sequence given the word sequence, the formula what we saw, we can apply that formula for race as a noun and race as a verb. So in both cases we can see okay what is the probability, wherever it is coming higher we need to take that. Okay, so if you see this one like the same sentence is given here, and if you compare what is difference in this tag, the difference is only in this case this is verb, whereas in this case this is noun. Okay, so I can find out the probability of this sequence given this sentence, then find the probability of this sequence given the same sentence. Wherever it is higher, I can take, okay, that would be my right tag given the training data set. Or else, there can be a smarter approach. What you can do, see, till this point, I think it would be there. Huh. Till this point, if you see, the secretariat is expected, these are what, noun verb verb, this is also saying noun verb verb. So somehow whatever probability you will calculate or multiply and find out, let's say for from this to this, everything will be same, right? So I can treat it as a constant because here let's say zero point 0.5, it here also it will be zero point 0.5. So it doesn't contribute in deciding what would be your decision. So basically you can take it as a constant. And in the similar way, suppose this one, this tomorrow given nr, tomorrow given nr, these are also same, so it also doesn't contribute. So basically this portion and this portion, they are just some constant, you can say it's constant. And what is the variable? The variable is from to we are transitioning to verb, whereas here from to we are transitioning to noun, right? So these things will vary. These for the first sequence, what is the probability here? For the second sequence, what is the probability here? If I can calculate this probability, then whichever will be higher I can take that instead of finding out the whole sequence probability for two cases, right? So it will also reduce our time because this is what the determining factor for our decision, right? So that is what they have done it here. So if you see they didn't say give the data set, they directly said okay the probability of noun given to is this, uh, okay, noun, okay, noun given to this one, okay, they have given this transition probability, noun given to, then they have also given verb given to this probability they have given, then race given nn, so race given nn, this one, race given vb, this one, nr given vb, this thing, nr given nn, where is that, nr given nn, sorry, nr given vb, nr given nn, so all these probabilities they have given. So as we see, all these portions are already constant. We can just exclude our probability calculation. We need to just take this portion and this portion, find out the probability using this HMM rule, and then we can see the probability is higher in this case where the race is a verb, right? So what we can say for this race word, the tag would be verb, right? So if the question asks what would be the tag for race, you can say it is verb. But if it asks, okay, what is the correct tag for this sequence, then you need to say the correct tag would be NNP, BBZ, BBN to BBNR. Okay, so this will be the right tag. Okay, so I think I have covered everything whatever has been given in ma'am's PPT. If you guys have any questions, something you can ask.
No questions. Very well explained, Sanjukta. Thank you.
Okay, thank you.
Thank you very much, Samyukta. It's very clearly and patiently you explained the things. Thank you very much. Do you have any example problems?
Uh, Example problems? No, I don't have. But it will be the same thing. Actually, I saw the question. It will be same thing only. You have to just apply the formula and find out where it is maximum. So,
Okay,
yeah.
good. Thanks. So it be if it is direct, then we can just add the use the formula. And please share with me your file what you are sharing. So
This
once,
one,
yeah,
this is, I just took it from ma'am's PPT so that it would be easier for me to explain. I'll share it once again. Just hold
yeah,
on.
no problem.
Yeah, this looks much cleaner and very easy to understand.
Yeah, you covered only the important points here. Okay, just
Yeah.
summary of all the discussion. I also went through the lecture three. You concised it in a much shorter form. That's good.
How
I
will
will.
I share, like in here in this chart? I want to share.
No, you share it with me the
Yeah.
PDF to me.
It's a PPT. I
Yeah,
made it.
no
Okay.
problem.
Okay.
I
Or
can
else you can share in the NLP group also if you have.
NLP group
Okay. Okay.
also. No,
Okay.
I will share along with the recording so that it all goes in pair because sometimes
Yes.
people miss. They send the recording after then there will be hundreds of discussion points. Then we'll share the
Yeah.
PDF. I would share together in all
Okay.
the groups, whatever group I have, G5, SEM3, everything. Okay.
Okay. Okay. Fine. Yeah.
Yeah, and Nishit, you can stop the recording now, and once you able to upload it to the YouTube, please send me the link. I will forward the link along with the PPT or to all the groups.